On May 20th, 2024, Microsoft unveiled a Windows feature that seemed to turn the personal computer into a machine that remembered everything. Recall, built for a new class of Copilot plus PCs, could preserve snapshots of what appeared on screen and make that history searchable later. The reaction was immediate because the idea sounded less like a productivity tool than the final form of operating system surveillance. Within weeks, Microsoft changed the rollout, tightened authentication, and made saving snapshots something users had to explicitly enable. Yet one fact complicated the outrage. Microsoft said recall snapshots were processed locally and were not uploaded to its cloud. That contradiction matters because the most visible privacy controversy in Windows 11 was not the clearest example of its telemetry. The deeper system was already there, quieter and harder to see, producing structured diagnostic events as Windows performed ordinary work. Boots, crashes, updates, driver states, hardware characteristics, app compatibility, and feature behavior could all become diagnostic signals. There was no single secret microphone hidden in the kernel, and no public evidence that every keystroke was being streamed to Redmond. What existed was more consequential in a different way, a commercial operating system designed to continuously measure its own use. Microsoft calls much of this diagnostic data, and the distinction is important because telemetry can serve legitimate engineering needs. It can reveal a broken driver, a failed update, a battery problem, or a crash pattern affecting thousands of otherwise unrelated machines. But the same architecture can also describe what hardware people own, which features they use, and how they move through the interface. And when those signals meet an online identity, recommendation systems, cloud services, advertising surfaces, and paid upgrades, the picture changes. The question is no longer whether Windows 11 collects data. Microsoft documents that it does, including a required diagnostic layer. The real question is what happens when measurement becomes inseparable from the design, economics, and future direction of the operating system. Windows once arrived mainly as software licensed to a machine. Windows 11 increasingly arrives as the front door to a persistent service ecosystem. That shift did not happen overnight, and it did not begin with recall. Its roots run through Windows 10, cloud identity, telemetry, and subscriptions. By 2026, Microsoft was publishing detailed catalogs of diagnostic events for current Windows 11 releases, exposing the machinery in plain sight. To understand the monetization of the user, the mystery is not hidden code. It is why so much of the operating system now needs to observe itself. When Windows 11 began rolling out on October 5th, 2021, the public story centered on a redesigned start menu, stricter security requirements, and a cleaner interface. Underneath that presentation, however, sat an operating model inherited from Windows 10. Windows was no longer treated as a static product that changed mainly when a new version shipped. It was a continuously serviced platform. That distinction changes the economics. A boxed operating system only needs to know enough about a computer to run. A continuously serviced platform benefits from knowing which devices fail, which drivers crash, which features are ignored, which applications dominate, and which configurations create trouble. Telemetry becomes part of the feedback loop that decides what the next update should fix, prioritize, delay, recommend, or remove. Microsoft's own enterprise documentation names the core collection mechanism plainly. Structured diagnostic events and diagnostic logs can be managed by the connected user experiences and telemetry component, while crash reports and crash dumps are handled through Windows error reporting. These are not rumors derived from packet captures. They are described as normal components of the operating system's engineering and support infrastructure. The word telemetry can make every event sound equally invasive, but the categories matter. Required diagnostic data is designed to remain available even when a user declines the optional layer. Microsoft says it uses this required data for security, reliability, performance, compatibility, accessibility, privacy, energy efficiency, and product improvement. The baseline exists because Microsoft considers it necessary to operate Windows as a serviced system. At that baseline, Windows can report information about devices, peripherals, settings, installed applications, update behavior, reliability, and compatibility. Current Microsoft catalogs contain named events tied to boot state, recovery operations, edge updates, setup processes, and hardware conditions. Some are triggered by specific actions. Others appear when a component fails, changes state, installs, updates, or attempts to repair itself. This is where the phrase high-frequency telemetry needs precision. Microsoft does not document Windows 11 as transmitting every user action at a universal fixed interval. The architecture is largely event-driven, but a modern operating system generates enormous numbers of meaningful events. Updates occur, apps launch, services change state, networks reconnect, errors happen, and components measure performance. A busy system can therefore produce a steady diagnostic stream without a single master timer. That stream can reach surprisingly deep into the machine's characteristics. Microsoft's optional data documentation lists processor architecture, speed, core count, manufacturer and model, OEM information, firmware details, memory, storage, battery characteristics, device identifiers, and attached peripherals among the kinds of device and configuration information Windows can use. Hardware is not merely the stage on which Windows runs. It can become part of the diagnostic description. Optional diagnostic data expands that picture. Microsoft says it can include richer device information, product and service usage, product and service performance, software setup and inventory, browsing-related information in Microsoft contexts, and enhanced error reporting. App usage can include launch counts, duration, foreground or background state, interaction methods, navigation through features, and the timing of activity. Some optional error reporting can also become more sensitive, simply because failures are messy. Microsoft warns that crash information can include the memory state of a device and may unintentionally contain pieces of files that were open when a crash occurred. That is not the same as intentionally uploading a document, but it demonstrates why diagnostic systems deserve scrutiny. Troubleshooting data can expose more context than the name of an error code suggests. Microsoft attempts to separate these purposes through settings, categories, pseudonymization, sampling, and published schemas. Users can open the Diagnostic Data Viewer to inspect events captured from a device and export them. That transparency is significant because it turns telemetry from an invisible abstraction into something observable. Yet the very need for such a viewer also reveals how extensive the diagnostic vocabulary of modern Windows has become. For Microsoft's engineers, that portrait has obvious value. A driver that crashes only on a certain GPU revision can be identified across thousands of machines. An update can be blocked when a particular peripheral is known to cause instability. An application compatibility problem can be prioritized according to how many people actually run the software. In this sense, telemetry reduces guesswork and can make Windows safer and more reliable. But engineering value is only the first layer. Microsoft also states that diagnostic data helps it understand how people use, or do not use, operating system features. It has described using such information to study start menu behavior, feature adoption, and application switching. Once a platform can measure what users ignore, discover, launch, pin, uninstall, or abandon, product design can become increasingly behavior-driven. This distinction is essential because there's no credible basis for claiming that Windows diagnostic data is simply dumped into a marketplace and sold as a dossier. The documented model is more subtle. Microsoft can use data to improve products, personalize experiences under certain settings, and support recommendations in advertising. The economic value comes from shaping an ecosystem, not necessarily from selling a file labeled with a user's name. Windows 11 makes that ecosystem difficult to separate from identity. Microsoft's current system requirements state that Windows 11 Home and Windows 11 Pro for personal use require internet connectivity and a Microsoft account during initial device setup. That requirement does not apply identically to every managed enterprise scenario, and a local account can still exist later. But the default consumer journey begins by attaching the machine to an online identity. That moment matters more than it looks. A local account identifies a person only to one installation. A Microsoft account can participate across Windows, the Microsoft Store, OneDrive, Microsoft 365, Outlook, Xbox, Edge, device recovery, purchases, synchronization, and the company's privacy dashboard. The operating system stops being merely the environment in which services run. It becomes the authentication layer through which the services recognize continuity. In March 2025, Microsoft removed the bypass nro.cmd script from Windows 11 Insider builds, saying the change would ensure users completed setup with internet connectivity and a Microsoft account. In October of that year, Microsoft said it was removing additional known mechanisms for creating a local account inside the out-of-box experience. The company argued that those bypasses could skip critical setup screens. Identity alone is not monetization. The commercial significance appears when identity intersects with surfaces that can recommend, promote, synchronize, upsell, and measure. Windows 11 includes settings for an advertising ID, app launch tracking used to improve start and search results, suggested content and settings, and personalized recommendations. Microsoft explicitly tells users that disabling the advertising ID may make ads less relevant, not eliminate ads entirely. In 2024, Microsoft added app promotions to the recommended section of Start for some Windows 11 users and provided a setting to turn those recommendations off. The important part was not one promoted app. It was the precedent. The Start menu, once understood primarily as a launcher for software the user had chosen, could also operate as a distribution surface for software the platform wanted the user to discover. Microsoft's own privacy language becomes especially revealing around what it formerly called tailored experiences, and increasingly calls personalized offers. When enabled, Windows diagnostic data can be used for personalized tips, ads, and recommendations. Microsoft says those experiences can include Microsoft and third-party products, services, apps, features, and hardware. A low storage warning, for example, can become an opportunity to recommend cloud storage or hardware. Optional usage data can sharpen that context further. Microsoft documents that information about which apps are most used can support recommendations for similar or complementary applications. Installed app information can support Microsoft Store recommendations. Device capabilities can be used to suggest suitable software. Performance problems can produce recommendations for diagnostic tools. Each case turns knowledge of the machine into a potential decision point. This is why the system's commercial value is better understood as conversion infrastructure. Windows has privileged knowledge about device state and privileged access to interface real estate. It knows when storage is low because it manages storage. It knows whether a pen is available because it enumerates hardware. It knows which apps are installed because it manages software. When recommendations are enabled, those facts can become targeting signals. The term targeting should still be used carefully. Microsoft says it does not use the contents of crash dumps, websites you browse, speech, typing, or inking input for tailored experience personalization when such optional data is received. It also gives users controls over optional diagnostics and personalized offers. These boundaries matter because an accurate privacy critique has to distinguish documented personalization from the far broader claim that every piece of user content is mined for ads. Microsoft's financial reports make those incentives visible without proving a direct causal link to any specific telemetry event. Windows OEM licensing remains a real business. So do Microsoft 365 subscriptions, OneDrive-related consumer services, the Microsoft Store ecosystem, and search advertising. In fiscal 2025, Microsoft reported growth in Windows OEM and devices, Microsoft 365 consumer, and search and news advertising within the same broader consumer computing portfolio. Windows 11 also arrived with a second form of leverage, hardware eligibility. Microsoft required TPM 2.0, secure boot capability, supported processors, and other minimum specifications for officially supported installations. The security rationale was substantial. TPM-backed keys, measured boot, credential protection, and modern driver expectations can reduce real attack surfaces. Treating those requirements as nothing more than a sales conspiracy ignores the technical case. But the consequence was still commercial. Millions of functioning PCs could not move into Windows 11 through the supported path because they lacked approved hardware characteristics. When Windows 10 support ended on October 14, 2025, many owners faced a choice among extended support, unsupported configurations, alternative operating systems, or new hardware. Security policy and hardware replacement became intertwined even when Microsoft did not manufacture most of the PCs being replaced. That is the more defensible meaning of hardware-linked monetization. It is not that TPM 2.0 transmits advertisements. It is that the Windows platform defines which hardware remains inside the supported future, while Microsoft and its OEM partners benefit from an ecosystem in which new Windows capabilities increasingly align with newer devices. The boundary of software support can influence the timing of hardware purchases. Copilot Plus PCs pushed that relationship further. Microsoft defined a new class of Windows machines around neural processing hardware capable of at least 40 trillion operations per second, then reserved certain AI experiences for that class. The NPU was not added to spy on users. It was added to run AI workloads efficiently on device, but it also created a new premium hardware boundary inside the Windows ecosystem. Recall became the symbol of that boundary because it required the operating system to understand far more context than conventional desktop features. The original concept continuously created snapshots that could later be searched semantically. From a privacy perspective, that sounded like a historical archive of a user's digital life. From a product perspective, it was a new reason to buy hardware capable of local AI indexing. The initial design triggered enough concern that Microsoft changed it before broad release. The company made snapshot-saving opt-in, strengthened Windows Hello requirements, and redesigned protection around encrypted storage and virtualization-based security. Current documentation says recall processing occurs locally, snapshots are stored on the device, and they are not sent to Microsoft or shared with third parties simply because recall is running. That correction is important because it exposes a recurring mistake in debates about Windows privacy. Local observation is not identical to cloud telemetry. A feature can inspect the screen intensely and still keep the resulting data on the machine. Another feature can collect a tiny technical event and send it to Microsoft. Sensitivity depends on content, destination, retention, purpose, security, and user control, not just how dramatic the feature appears. The contrast with conventional diagnostics is striking. Recall attracted global attention because users could imagine the screenshots. Required diagnostic events rarely generate the same reaction because they look like JSON fields, event names, version numbers, booleans, counters, and identifiers. Yet those mundane records are the enduring nervous system of Windows as a service. They operate across far more machines than any one Copilot Plus feature. Microsoft publishes enough detail to show that this nervous system reaches down into low-level operating behavior. Current required event lists include boot information, recovery state, setup transitions, update operations, hardware environment, and error conditions. Calling all of this kernel-level surveillance is inaccurate because events originate across many layers, but some signals plainly reflect activity close to the system core rather than only what happens inside a user-facing app. The distinction matters because the kernel is not the monetization layer. It schedules threads, manages memory, enforces security boundaries, talks to drivers, and mediates hardware. Commercial logic usually appears higher up. Identity services, recommendation systems, the shell, Microsoft Store, search, cloud prompts, and subscription experiences. Low-level telemetry feeds understanding. Higher-level product surfaces decide how that understanding is turned into action. It also explains why enterprise Windows often feels different from consumer Windows. Organizations can apply policy, mobile device management, diagnostic controls, store restrictions, cloud content rules, and account configurations at scale. Microsoft provides documentation for disabling tailored experiences and restricting consumer features. The existence of these controls demonstrates that many behaviors are configurable, but it also highlights how much administrative effort can be required to define a quieter version of Windows. For individual users, the controls are more fragmented. Diagnostic data has its own setting, personalized offers have another, advertising ID has another, app launch tracking has another, suggested content has another, widgets, Edge, Microsoft account privacy, location permissions, cloud backup, and individual apps can each add separate choices. Privacy becomes less like one decision and more like maintaining a configuration across a living service. At the same time, it would be wrong to pretend Microsoft offers no meaningful controls. Optional diagnostic data can be declined, personalized offers can be disabled, advertising personalization can be changed, diagnostic events can be viewed, some device-based diagnostic data can be deleted. Enterprise administrators have additional policy options. These controls complicate the strongest accusation. Windows 11 is not a machine in which every category of collection is mandatory and uncontrollable. The more unsettling argument is subtler. Required diagnostics mean there is no ordinary consumer mode in which Windows behaves exactly like an air-gapped operating system, while still using all cloud-dependent features and services. The platform assumes a baseline of communication because servicing, security, reputation systems, updates, and account integration depend on communication. Connectivity is not an accessory bolted onto Windows. It is one of its operating conditions. Digital sovereignty therefore becomes less about whether a computer is technically yours and more about which decisions remain exclusively yours. Can setup finish without a cloud identity? Can all non-essential data leave the machine only after explicit consent? Can a supported installation survive on older hardware? Can recommendations be removed permanently? Can the operating system remain fully functional if the user rejects the surrounding service ecosystem? Windows 11 answers those questions unevenly. Home and Personal Use Pro setup push strongly toward Microsoft identity. Optional telemetry and personalization remain controllable. Required diagnostics remain. Hardware support rules remain vendor-defined. Some cloud experiences can be ignored or removed. Others are woven into setup or system components. The result is not total loss of control, but a shift in where the default balance sits. Telemetry strengthens that logic by making outcomes measurable. If Microsoft changes a start layout, it can study whether behavior changes. If a feature causes crashes, it can see the reliability cost. If an offer is ignored, product teams can alter placement. If hardware combinations fail an update, deployment can be paused. The same feedback loop can improve quality and optimize engagement because technical health and user behavior coexist inside the same platform. This dual use is what makes telemetry politically difficult. The data that helps fix a graphics driver can also reveal which hardware is common. The data that shows a feature is undiscoverable can justify a more aggressive prompt. The data that identifies low storage can support a useful warning or a commercial recommendation. The collection mechanism is not inherently malicious. The governance of purpose determines how power is exercised. That fact undermines the claim that telemetry is technically unavoidable in one fixed form. Much of it is a product and policy choice. Components can be separated. Purposes can be restricted. Defaults can change. Collection can be sampled. Features can be made opt-in. The recall redesign proved this dramatically. A privacy model presented one way in May 2024 looked materially different after public scrutiny. So the central issue is not whether Microsoft is capable of building privacy-preserving technology. It clearly is. Recall's local processing, virtualization-based protection, encryption, and user authentication show how far Microsoft will go when a feature's sensitivity is obvious enough to demand architectural defenses. The harder question is why comparable privacy intensity is not always the default philosophy for less visible forms of data collection and commercial steering. Part of the answer is scale. Windows supports an extraordinary variety of processors, drivers, peripherals, applications, and enterprise configurations. Microsoft cannot reproduce every failure in a laboratory. Diagnostic data provides evidence from the field. Removing that evidence would make updates riskier and support slower. A desktop ecosystem this broad genuinely benefits from telemetry in ways that a tightly controlled appliance might not. That does not make every Windows user a commodity in the crude sense. Microsoft earns substantial revenue from licenses and subscriptions people deliberately purchase. Many telemetry uses deliver real benefits. Many recommendations can be disabled. Many users actively want synchronized settings, OneDrive backup, account recovery, web search, store apps, and AI assistance. Convenience is not a trick merely because it also supports a business model. But convenience changes the bargaining position. The more valuable the integrated services become, the harder it is to separate the operating system from the account. The more updates depend on measured compatibility, the more normal telemetry feels. The more cloud storage rescues people from lost files, the more natural cloud prompts appear. A platform can expand its commercial reach through features users genuinely appreciate. This is why the strongest critique of Windows 11 is not that Microsoft secretly replaced the operating system with spyware. That claim is too simple and often technically wrong. The stronger critique is that the operating system has been redesigned around a permanent relationship in which observation, service delivery, product improvement, identity, and monetization increasingly occupy the same technical environment. The strongest defense is equally concrete. Without diagnostics, Microsoft would have less evidence for fixing failures across a massive hardware ecosystem. Without account integration, many synchronization and recovery features become harder. Without modern security requirements, credential and boot protections weaken. Without on-device AI hardware, features like a recall would require more cloud processing, not less. The architecture solves real problems while creating new dependencies. Those two truths can coexist. A system can be more secure against malware while giving its vendor more influence over setup. It can process sensitive AI context locally while sending ordinary diagnostic events remotely. It can give users privacy controls while placing commercial recommendations inside system interfaces. It can avoid selling raw telemetry and still extract economic value from what telemetry teaches the business. By 2026, the documentation itself made this duality difficult to deny. Microsoft published extensive lists of required diagnostic events for current Windows 11 versions, described how optional usage and configuration data could support recommendations, and maintained controls for viewing diagnostic records. The system was not hiding the existence of telemetry. It was normalizing telemetry as a standard property of personal computing. That power to draw the boundary is the real center of digital sovereignty. Users can toggle many settings, but Microsoft defines the menu of possible toggles. It decides which diagnostics are required, which hardware is supported, which setup paths are official, which features become cloud connected, and which commercial surfaces appear in the shell. Control exists inside a framework whose outer limits belong to the platform owner. Return to May 2024, and the recall controversy looks different. The feature frightened people because it made observation visible. Screenshots were intuitive. A timeline of past activity felt personal. Public pressure forced design changes that were easy to understand: opt in, authenticate, encrypt, keep the data local. The drama centered on a feature users could see. The enduring telemetry system is harder to visualize because it is composed of events rather than pictures. A device model here, a crash state there, an app launch count, an update result, a storage condition, a hardware capability, individually mundane, collectively powerful. They allow Windows to know enough about its installed base to improve it, segment it, guide it, and build business decisions around its behavior. That is what Windows 11 has transformed into. Not literally a piece of telemetry hardware, but a hardware-bound service platform whose software continuously measures the machines it inhabits. The measurement can protect users, repair failures, and improve compatibility. Under optional personalization, it can also help decide which products, services, apps, and hardware are placed in front of them. The critical question is therefore not whether telemetry should exist at all. A platform this complex has legitimate reasons to measure itself. The question is whether the user can meaningfully understand the measurement, refuse what is not necessary, keep sensitive context local, and prevent diagnostic insight from quietly becoming commercial pressure. Recall showed that Microsoft can redesign a feature when that boundary becomes politically impossible to ignore. The future of Windows privacy will depend on whether the same principle expands beyond the most controversial AI features. Collect less by default, separate purposes clearly, process locally when possible, and make commercial personalization unmistakably optional. Because the most valuable thing Windows learns from a user may not be a secret document, a password, or a private message. It may be the pattern of ordinary behavior surrounding them, What breaks, what launches, what hardware is present, what fills the disk, what goes unused, what gets clicked, and what kind of prompt arrives at the perfect moment. That pattern is enough to improve an operating system. It is also enough to shape an ecosystem. And once the operating system becomes the place where engineering intelligence and commercial opportunity meet, the PC is no longer just executing the user's instructions. It is continuously helping its maker understand what the user might do next.